The first one can be called pre-tension. The second one can be called post-tension. We have two techniques. The first one, probably most used in the company which produce pre-stressed unit in a company, not on site. So we have form of concrete, and you will put your cable, whatever the shape, and you have jack here and another jack, or probably dead end, whatever, and we have hydraulic jack. This jack is pulling this cable and staying pulling the cable until you pour concrete and the concrete is hardening and you get the full strength of concrete. Then go ahead and release this cable from this side and this side. This is called pre-tension. That means you applied the post-tension first, then you poured the concrete and wait until the concrete gets the strength. Not the full strength, but at least acceptable strength before releasing the force. This is the first technique. This technique is used most of the time in the pre-stress companies, not on site. It's very difficult to put the hydraulic jack waiting to pull this cable until the concrete. You are talking about 7 or 14 or probably 28 days. It's not common. In a bridge on site, you can apply this technique. We have another technique, which called post-tension. What is the meaning of post-tension? We have the concrete formwork. Before doing anything, I will put a tube. PVC tube or whatever, something to maintain this position without any concrete. Then go ahead and put your reinforcement. Go ahead and pour the concrete. I didn't apply any pre-stress. I didn't put my cable. I didn't do anything. I just put a tube at the location of the expected cable. Then I poured my concrete. The concrete is good, hardening, strength. After 7 days, 14 days, 28 days, then I will come to put my cable in this tube. Then in a few minutes, I will apply the pre-stressed force in few minutes. Then plug this end with anchor, and then plug this end with anchor. Then I will release. Then the tendon would like to go back. So in this technique, we poured concrete. We waited for full strength, whatever the time. Then we will apply the pre-stressed. So we have two techniques, one called pre-tension and one called post-tension. This one most of the time is used on site during the construction of the project. So as I told you, the hydraulic jack can apply pre-stress in few minutes, just a few minutes, because you don't need to wait until concrete gets the full strength. No, the concrete is already ready to be applied by pre-stress. Okay, Roberto?
Yes, I understand now.
Yeah. Okay, let me start. Yeah, last time I talked about test for fresh concrete. By the way, when you are pouring concrete, the concrete can be called fresh concrete. So we have a common test which called slump test. Your concrete is still fresh, so you need to judge if this mix is good or not. So by the result, you can judge this mix will need more water or less water. If you need to add more water, that's fine. But if you need less water, how can I do this? You can reject the mix and ask the driver of the truck to go back to the company. After concrete is hardening, probably after 28 days, we have another test, which called very, very famous test, compressive or compression test, to get the compressive strength of concrete. But you need to prepare some samples, cylinders, concrete cylinders. We have two standards. Probably you can bore cylinders with diameter 4" and the height 8", or diameter 6" and the height is 12". Both of them works. The standard said 4" diameter and 8" height, or 6" diameter and 12" height. There is a plastic tube, plastic cylinders. You can buy them and pour your samples and wait for 28 days. Then you can apply or you can run the compression test. Remember, from mechanics of material or material engineer, strength of material, if you have cylinder and you are applying force, we are increasing this force gradually. So we can expect stress equal B, the applied force, divide the cross-section area of the cylinder. I believe you can figure out the area of the cylinder, which is pi divide 4 times diameter square. What is the value of diameter? As I told you, which standard dimension you used. Is it 4" times 8 or 6" times 12? So you need to figure out what is the used diameter. So once you figure out the diameter, I can figure out the area of the cylinder. During the test, during you are running the test, this machine can give you the applied force. Every 10 seconds, or every 5 seconds, or every 1 minute, whatever, you can read the applied force. So I can figure out the applied force during the test. If you divide the applied force by the cross-section area of the cylinder, I can figure out what? Stress. That's right. Also, during the test, the machine can give you what is the contraction of this cylinder. I know concrete is very strong, but whatever the material, if you apply compression force, we can expect contraction. So the machine during the test can give you what is the value of contraction, 0.1", 0.2", 0.3", whatever the value. From strength of material, you learned. We have something called strain. Do you remember? Strain equal the elongation or the contraction, delta, divide the original length. Do you remember the original length? The original length of the cylinder. Yes. I told you we have two standard dimensions. 4" times 8, so 8 is the original length, or 6" diameter times 12, so 12 will be the original length. So please, you need to decide which dimension I will use. I will buy. Which dimension I will buy the plastic cylinders. And the machine during the test can tell you what is the value of contraction, what is the value of applied force. So during the test, I can figure out what is the value of stress and what is the corresponding value of strain until you reach this failure of concrete. If you set up a relationship between stress and strain on the horizontal axis and stress on the vertical axis, you can reach this curve, which is called stress-strain curve of concrete. This curve, please put it in your mind. You need to remember this curve all the time if you are working with concrete. The relationship between strain on the horizontal axis and stress on the vertical axis, it will look like this. One more time, how can I construct this curve? I told you the story. The story is you need to decide first which plastic cylinder I will buy. So let's try, or let's assume we bought plastic cylinders 4-inch diameter times 8-inch height. I poured these cylinders with concrete and waited for 28 days. Then I will get this concrete out of the cylinder and I will apply the compressive force using compression machine. During the test, the machine will tell me what is the applied force P and what is the corresponding delta. This value of delta will be very, very, very small, 0.0001 or 0.005 or 0.003, whatever. So if you have P, I can figure out the stress. P divide area. Don't forget this area. I can figure out the strain. What is the value of strain? This contraction delta divides the original length, L naught. If you construct a relationship, because we have many values of P and many corresponding value of delta during the test until failure, if you construct a relationship between strain and stress, you can reach this relationship. The maximum value of stress can be called compressive stress of concrete. This one is very, very, very important. We will design using this value of concrete, which called compressive strength of concrete, which is the maximum stress you reach during the compression test. This value is very important. During you are working as engineer, please remember this curve and what is the meaning of the highest value of this curve. Any question so far? Any question so far? So we have a good story here about the compression test. And the machine can give you the data for applied force and contraction, so I can figure out the relationship between stress and strain. Once you construct your stress and strain, I can figure out the maximum value of stress, which can be called compressive strength of concrete. This value, most of the time, probably between 2,000 until 6,000 psi for normal concrete. If you go up 7,000, 8,000, 10,000, you are talking about high strength concrete, which is very, very, very strong. High strength concrete. But the normal concrete, something between 2,000, very weak concrete, 6,000, very strong concrete. Something in between, but probably 3,000 or 4,000. This is the common concrete we are using during construction, 3,000 to 4,000 psi. What is the meaning of this value? The meaning of this value is the highest value in this curve. And how can I construct this curve? Go back to this compression test. You can understand what is the meaning. Okay, this concrete in compression. We have concrete in tension. If you would like to figure out the tensile strengths of concrete, actually, I cannot handle this cylinder and apply tension like this, which is called direct tension. I cannot. Nobody can do it because you will get failure at this catch area. This area, I cannot, because concrete is very weak in tension. So we have indirect test, which called split cylinder test. I will put my cylinder like this, not vertical but horizontal, and I will apply the force until you have failure, splitting in the concrete. From this formula, this equation, 2 times the applied force until failure, divide by d diameter, L the length, I can figure out the tensile strength of concrete. So I cannot handle concrete cylinders vertically to apply tension force. So I will handle it horizontally, and I will apply the force like compression, but this force will cause splitting in the concrete cylinder. By this equation, I can figure out the tensile strength of concrete. This test is very common in concrete, which is called indirect test. Indirect tension test. Why it's indirect? Because if you are watching, you will see this force is applied in compression on the cylinder. But it's indirect because this force will cause splitting. This splitting means we have tension to split this cylinder. So we have indirect tension on the concrete cylinder. We have another test also, which is called Flexural Test. We have a concrete beam, and you are applying one concentrated load. Sometimes it's a 2 concentrated load. And based on the value of the maximum load, I can figure out the tensile strength of concrete, but this one is more common. This curve is very important. What is the meaning of this curve? We have relationship between strain and stress for concrete in compression. So we have this curve. So this curve, relationship between strain and stress of concrete in compression, that I discussed before. One more time, the highest value here can be called F prime C, which is the compressive strength of concrete. Can you draw a relationship between strain and stress for concrete in tension from this test? Yeah. Here is the relationship. And at this value, we have the maximum value, which is called tensile strength of concrete. Anybody can recognize anything from this curve? Do you think you can conclude any information from this curve? Any conclusion? Guys. Hi, Brock. Thank you for coming. Any conclusion from this curve? Yeah. Yes, tension curve is very smaller. That means concrete is very strong in compression and very weak in tension. If you go back, this is the main reason why we are using steel reinforcement. Because concrete is very strong in compression, but very weak in tension. So concrete works well in compression, and the steel and the concrete is not work well in tension. So we need to add steel reinforcement, and the steel reinforcement will be added in the tension zone. If you can decide the tension zone in concrete, at this zone, we need to add reinforcement. How much? This course will let you know how much. So, but this curve is very important to understand. Concrete in tension is nothing. So all the time we neglect concrete in tension. But concrete in compression is strong, very strong. Okay. We have something called time-dependent behavior, effect of creep, or effect of shrinkage. What is the meaning of creep? The meaning of creep is a very simple description. If you have a beam, concrete beam, supported here and supported here, and you put applied force P. Do you remember from last semester we learned that if you have a beam with applied force, we have deflection. Do you remember something like this? We learned many methods to calculate this deflection. So this deflection Y will increase with time. So the force B is constant, no change. For 10 years, or 5 years, or 20 years, if you draw a relationship between time and this deflection, remember, this load is constant. Everything is constant, no change, nothing change. But the only change on the only parameter is time. If you draw a relationship between time after 1 year, 2 years, 3 years, 4 years, 5 years, 10 years, 20 years, 50 years, you will find increase in deflection. This deflection will increase. However, the applied force is constant. This phenomena called creep of concrete. This called time-dependent behavior, because nothing changed. The applied load is the same, the beam is the same, everything is the same, but only time is a change. So we can expect deformation with time. This is called creep. It's outside the scope of this course. But just to learn what is the meaning of creep. Dry shrinkage. Do you remember? Sometimes we have concrete on for a pier and bridge. So we can expect wet and dry cycles. During the rainfall, we have wet concrete. During the summer, no rainfall, so we can expect dry. So wet and dry cycles, we can expect shrinkage of concrete, and we can expect cracks on the concrete surface. These cracks called shrinkage. Cracks. This shrinkage will affect on concrete behavior, especially for deflection and stresses. So shrinkage related to water in concrete. Also by time, let's think. We have concrete, we have wet and dry cycles for 50 years. So dry, wet, dry, wet, dry, wet, dry, wet. So we can expect weak concrete, we can expect more cracks, we can expect failure. Reinforcing bar. As I told you, concrete is very strong in compression. Nothing needed, no help needed for concrete in compression. But concrete is very weak in tension, so we need help. Who is helping? reinforcement, rebars, steel rebars. We have different size according to US units. We have number 2, number 3 bars, number 4, number 5, number 6, number 7, number 8, number 10, 9, number 10, and whatever. Each size of these rebars has diameter and has area, cross-section area. So this one is the cross-section area for each bar. This one is the diameter for each bar. This one is the common name, number 2, number 3, number 4, or whatever. We are talking about US. If you are in a different country, we have a different name, number 6, number 10, whatever. Okay? Remember, this table is very, very important. Keep it with your hand during the exam, during your life, actually. Why? During the course, based on your calculations, we can figure out the required area steel, total required area steel, for example, 3.6 inches square. But I don't care. What is the meaning of 3.6 inches square? We need to convert this area of steel of how many bars and which bar. So you need to select, for example, I will select this number 6 bar. So how many? You need to divide this required area by the area of 1 bar of number 6. If you divide the total area by the area of 1 bar, I can figure out the number of bars. So based on your calculation in this course, you can figure out the total required area. Then from this table, you can pick up, it's up to you. It's up to you. You can pick up a bar, size of bar, for example, number 6. So the area of number 6 bar is 0.44 inches square. So the required number will be the total area, the total steel area, divide the area of 1 bar. I can figure out the number of bars. We will cover all of this stuff later. Also for steel reinforcement, the most common test is tension test. I did one last semester with the senior student. You have a steel rebar clamped between this head of the machine and this head, and you apply tension force this direction and this direction. Also, during the test, the machine can tell you what is the applied force. So I can figure out the stress, which equal F divide area of the cross-section area of the steel rebar. Also, during the test, the machine can tell you the corresponding elongation, delta. So the strain will be the elongation divided the original length. If you construct a relationship between strain and stress, you can reach this relationship. We have here a few points you need to remember. What is the meaning of this curve? This is a stress strain curve for steel reinforcement. At this point, we can expect yielding. At this location, plateau. At this point, which is the maximum stress, is called ultimate strength of steel. At this location, which is the fracture stress. Anybody remember from strength of material, what is the meaning of this line? And what is the slope of this line? What is the meaning of this slope of the relation, the linear relationship? Do you remember? Do you remember? For this linear relationship, what is the meaning of this slope? And we have here a law, which called Hooke law. That means your, wait for any answer. No answer? Guys, are you sleeping? Are you here? You should learn all of this stuff in strength of material or mechanics of material. Yeah, I know you are here, but what is the answer? Guys, the slope of this linear relationship called modulus of elasticity. Modulus of elasticity, which called E. From Hooke's law for this linear relationship, stress divide strain. We have a linear relationship between, in the elastic region. Elastic means if you remove the applied force, everything will go back, nothing will change. After this linear relationship, we have yielding. What is the meaning of yielding? The load is constant, but we have elongation. Then we have something called strain hardening. Strain hardening. All of this stuff you have to remember. All of this stuff. Keep this information in your mind. You should remember, learn all of this stuff in strength of material. Yes. Elastic deformation, the deformation of material can withstand. Okay, but the most important information here is the slope of this linear relationship called modulus of elasticity. E. Do you remember last semester we learned in deflection something divide E I. I is the moment of inertia, whatever. E is the modulus of elasticity of the material of the beam. E modulus of elasticity means the slope of the linear relationship between strain and stress. We have an example here. During the test, during the tension test, we have steel rebar with diameter. This diameter equal 0.503 inch. And the original length for this rebar is 2 inch. So L naught equal 2 inch. So from this diameter, I can figure out the area of the steel rebar. What is the area? By divide 4 times this diameter square. This area will be 0.198 inches square. So from the information is a problem, the diameter of the rebar is given, the original length is given, so I can figure out the cross-section area. During the test, I have this data. At load 0, we don't have elongation. If you apply 1.5 kib, you have elongation. 4.6, we have a different elongation. 8, we have an elongation. 11, until you reach 18.5, we have elongation 0.46. I need to construct, I need to draw the stress strain curve. Can you? Yeah, you said stress strain curve, but I have load elongation curve. So I need first to convert this data to stress strain curve. So I will construct another table with strain and stress. What is the value of strain? The elongation value, which is listed here from the test, divide the original length of the rebar, which is 2 inch. So, for example, first value here will be 0. Why? Because we don't have elongation 0. Divide 2 will be 0. The second one, 0.0005 divide 2. Your value here will be 0.005. 0.00025. Keep going. 0.015 divide 2, you can get the value here. 0.0025 divide 2, you can get the value here. Value here, value here, value here. So we have strain. What is the value of stress? Sigma equals the applied force load divide what? Area. The cross-section area of the rebar. So load is given 0, 1.5 kib, 4.6 kib, 8 kib, 11 kib, 11.8 kib, 11.8 kib, 12 kib, and so on. So I can figure out the value of stress. For example, 1.5 divide this area. So this value will be 7.57. The second one, 4.6 divide this area, 0.198. This one will be 23.23. So right now, I converted the listed data from load elongation data to a new data, which is strain stress data. If you draw a relationship, if you construct horizontal curve, which is a strain, and vertical curve, which is stress, you can do it with Excel. So for first one, 0 and 0. The second one, 0.00025 and the 7.57. So you can find a point here and 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 point here. So you can construct this curve. You will find something like this, which looks like this one. Once you construct this curve, I can figure out what is the modulus of elasticity. What is the modulus of elasticity? Do you remember? Yeah. Go ahead and measure the slope of this line. Linear relationship. What is the value of yield stress? Yield stress means if you reach this plateau, so the yield stress will be here. What is the value of ultimate stress? Ultimate stress means the maximum stress, the maximum one. What is the value of rupture stress? Rupture stress is the final or the last value of the curve. So I can figure out all of this stuff from my relationship once you draw the relationship between strain and stress. But remember, stress and strain from this data. How can I convert this data to stress and strain? By these two equations. Strain equals the elongation divide original length. Stress equals the applied load divide the cross-section area. Any question? I recommend, we have one problem like this one in your homework, so I highly recommend to use Excel. Use Excel. Don't try, you are a senior student right now. Don't try to draw this relationship with your hand. Please be professional. Finally, I will go through quickly. I will go quickly through these notes because we will cover all of this stuff during the course. We have two methods of design of concrete, and also for any design, we have very old-fashioned method which called allowable stress design, and we have common method which called ultimate limit state. We will use this one. But to explain the philosophy behind this method and this method, let me explain this outside. But please pay attention because I'm trying to explain the philosophy behind the design of the two methods. Remember, I told you that the relationship between strain and stress for concrete looks like this. And I told you right now, the relationship between strain and stress for steel looks like this. That's right. Do you think I will design a beam? We have concrete beam with steel reinforcement. Do you think I will design this beam due to load and this is the maximum load? So I will design this beam for the maximum load. Do you think if we have something unexpected, so this we reach the maximum load, but besides the maximum load, we have additional load, so failure will happen. Do you think we are designing in this case? No, we need to expect something cannot expect. So we need to take something called factor of safety. I know the maximum load can reach, for example, is 1000. I will not design for 1000. I need to take another factor of safety because I can expect something different in the future. So we have two philosophies. The first one, which called allowable stress design, very old method. Most of the standards right now starting to cancel it. But we need to understand what is the philosophy. The philosophy is you said the maximum load on this beam can reach 1000. Okay, I will keep the 1000 as it is. I will design for 1000. But for concrete, the concrete can reach here until this point. F prime C. After this point, we can expect failure. That's right? Yes. No. I will design concrete until this point only, which called FC. The maximum one can reach 4000. Okay, but I will not design for 4000. I will design only for 2000 only. The concrete can support more. No, I will not. Get the full capacity of the concrete. I will design only for 2000. What about the rest? The concrete can support until 4000. The rest can be called factor of safety. So for steel, for example, the steel can reach here for F yield for 50,000, or F ultimate can reach for 70,000. No, I will design only for 20,000. But the steel can support more. The strength of steel can support more. No, the additional support can be considered factor of safety. So for steel FS equal 20,000. So the philosophy of this method, which called allowable stress design, is keep the applied load as it is. Okay, I will not change the load, the calculation of load, the expected load, I will not change. But for material, I will reduce the capacity of concrete more, and I will reduce the capacity of steel more. If something happened in the future I didn't consider, we still have more strength of concrete can support, and I still have more steel strength can support. You got it? So I will design for the expected load, but I will let the material to support more. So concrete can support until 4000, but I will design for only 2000. Steel can support for 50,000, but I will design for only 20,000. If something happens in the future, the material can support, don't worry. We have factor of safety of material in material strength. This is the first one. The first philosophy. The second philosophy, which called ultimate limit state, most of the standard right now working or using this method, ultimate limit state. Hey, the concrete can support 4,000. Okay, I will use the full capacity of concrete. Wow. Remember, if you exceed 4,000, failure will happen. It's okay. Don't worry. For steel, I will use the full yield strength of steel, which is 50,000. Hey, if you exceed this value, we can expect more deformation in the building. It's okay. Don't worry. No, I'm worrying because you are using the full capacity of the material. Yes, but if I have dead load on the structure, I will increase it by 20%. The expected load on the building is, for example, 20 kip. No, I will not design for 20. I will design for 20 plus 20%. And if you have live load on the building, I will increase this live load by 60%. So the applied load will be 1.2 dead load plus 1.6 live load. Hey, the expected load on the building in the future only 60 kib. No, I will not design for 60. I will design for additional load. If this load is dead load, I will add 20% increase. If this one is live load, I will increase it by 60%. So my factor of safety is taken in the applied load and your material as it is. This is the philosophy of ultimate limit state. The philosophy of the allowable stress design is your load will be the same. I will not increase or decrease the applied load. Keep it as it is. But I take my factor of safety in material. So what will happen? If the applied load, which is 1,000, increase a little bit, the material can support, don't worry. For this one, you are reaching the full capacity of the material, but you are designing of a larger load. So the design load is 60, but I designed for 80. I designed for 100. So if the applied load 60, I'm still okay. If it's 61, I'm still okay. 62, 65, 70, I'm still okay because I already designed for a larger load. So the main difference between this method and this method, how do you apply the factor of safety? Factor of safety in this method applied for material. Factor of safety of this method applied for load. This is the main difference between this method and this method. It's a good question. How much does creep affect maximum strain and stress over the time? It depends on what is the mix proportional. Do you have how much sand, how much gravel, how much cement? What was the water cement ratio? How much water did you use during the mixing? Also, do you have compression reinforcement? We have many factors. If you go back to my note, Alex, we have many factors affecting the creep. This factor and this factor and this factor. What is the large coarse aggregate? What is the maximum aggregate size? We have many factors affecting the creep, but this one is very important. If you add compression steel reinforcement, just put it in your mind and I will explain it in more details later. From this point at this time, just to understand what is the meaning of creep, just deformation by time. Your applied load is constant, but deformation is increasing with time. We have factors can control this effect. What is the meaning of shrinkage? Shrinkage related to water in concrete. Dry concrete means more cracks on the concrete surface. cracks means make concrete weaker. Because if you have cracks, we can expect attack from any environmental change to the embedded reinforcement. If we have this attack, we can expect failure in concrete due to the corrosion of steel reinforcement.